The air above your head, right now, is doing something it is not supposed to do in May. The atmosphere at 5,000 feet over Washington, Philadelphia, and New York is somewhere between 64 and 73 degrees Fahrenheit in May. That is 2 to 3 standard deviations outside normal for the date, which means in any given mid-May, this air mass appears between 1 time in 50 and 1 time in 300. 5 separate National Weather Service offices use the words record-setting in their morning discussions. The records that fall over the next 48 hours will be the surface of the story. The number that explains them is sitting 5,000 feet above you. Stay until the end, and you will know exactly what they are not telling you and why it matters. If this video has you locked in, hit subscribe and stay with us. The next chapter of this story writes itself over the next 48 hours. Drop a comment with where you are watching from and whether the air feels different to you today. Now let's get into it. The air mass currently sitting over the eastern third of the United States is doing something it is not supposed to do in May. If you look at the surface temperature forecast, you see numbers. 96 in Washington, 97 in Philadelphia, mid-90s in New York City, upper 90s across the Virginia Piedmont. Those numbers will get the headlines today, and they will get the headlines tomorrow, because they are the kind of numbers that people can feel on their skin when they walk outside. But the surface temperature is not what tells you what is going on. The surface temperature is the last symptom of the problem. The diagnosis is sitting about 5,000 feet above your head. Meteorologists have a number they use to characterize an air mass independent of all the local things that can muddy a surface temperature reading. They call it the 850-millibar temperature. That is the temperature of the air at a pressure level of 850 millibars, which corresponds to roughly 5,000 feet above sea level, above the ground heating, above the urban concrete, above the trees, above almost everything that can fool a surface thermometer. It is what the atmosphere is doing on its own, without you in the way. And the 850 millibar temperature over the Northeast right now is somewhere between plus 18 and plus 23 degrees Celsius. In Fahrenheit, that is roughly 64 to 73 degrees at 5,000 feet up. In May, in a region where the climatological mid-May value at that altitude is closer to plus 5 to plus 10 degrees Celsius, roughly 41 to 50 Fahrenheit. You can see the problem. The National Weather Service office in Baltimore and Washington, which goes by the call sign LWX, looked at that air mass this morning and wrote a single sentence into their forecast discussion that is doing more work than it looks like it is doing. They said the 850 millibar temperatures will run, quote, plus 19 to plus 23 degrees C. That is their value. The Boston office, which goes by Box, looked at the same air mass and wrote that those temperatures are, quote, 2 to 3 standard deviations above climatology. That phrase, 2 to 3 standard deviations above climatology, is the part of the morning discussion that ought to stop you cold. A standard deviation is a measure of how far an observation sits from the long-term average for the same date in the same location. If you imagine the entire population of mid-May air masses over the Northeast for the last 50 years lined up on a chart, they form a roughly normal distribution. Most of them cluster near the climatological mean. The further out you go from the mean, the rarer the events become. A 1 standard deviation event is unremarkable. A 2 standard deviation event corresponds to roughly the top 2% of all mid-May air masses ever recorded at that location. A 3 standard deviation event corresponds to roughly the top 1/10 of 1% of all mid-May air masses ever recorded. The Boston Forecast Office is telling you, in operational forecaster language, that the air mass currently sitting over their region is somewhere between a 1 in 50 and a 1 in 300 occurrence for the date. That is the number. That is the diagnosis. Everything else in this video is a consequence of that number. When you have multiple independent National Weather Service offices spanning a region from Northern Virginia, through Maryland, through New Jersey, through New York City, through Connecticut, through Massachusetts, all looking at the same air mass, and all independently concluding that it is 2 to 3 standard deviations outside normal, the analytical coherence is itself unusual. Forecasters are not in the business of inflating their language. Their professional culture is conservative. They write expected before they write probable, and they write probable before they write record-setting. When 5 separate offices on the same morning write record-setting early season heat probable, it is because the air mass is not at the edge of the climatological envelope. The air mass is well outside it. The surface consequence of that air mass is what you are seeing on the forecast maps. The Baltimore and Washington office expects the hottest readings across the immediate I-95 metros and into the central Virginia Piedmont to land between 96 and 98 degrees Fahrenheit today. The New York City office, OKX, expects the urban corridor of northeast New Jersey, New York City itself, the lower Hudson Valley, and much of interior southern Connecticut to push into the mid to upper 90s, with the hottest readings concentrated across the parts of the metro furthest from the ocean. The Philadelphia office, PHI, expects highs in the 90s across most of the region, cooler only along the immediate Atlantic coast and at elevation. The Boston office expects the Connecticut and Merrimack valleys, where downslope flow off the surrounding terrain compresses and heats the descending air, to push into the mid-90s as well. Heat indices are running close to the air temperatures themselves because the boundary layer dew points are in the low to mid-60s, humid enough to make it uncomfortable, but not the swampy tropical humidity that drives heat indices 10 or 12 degrees above the actual temperature. The Philadelphia office is calling for peak heat indices between 95 and nearing 100. The Baltimore and Washington office is calling for heat index values, quote, similar to the air temperatures. That is the second symptom worth flagging. When the heat index nearly equals the temperature, the air mass is heating you up through pure thermal load, not through humidity slowing your sweat evaporation. It is the kind of heat that comes from above and from below at the same time, and it is the kind that catches you off guard if you are dressed for a normal mid-May day. Tomorrow, Wednesday, will be the second day of the dome. The Philadelphia office expects highs a few degrees cooler than today's because of increasing cloud cover ahead of an approaching cold front, but still in the lower 90s across most of the region. The New York City office sees the same setup, with slightly cooler high temperatures and slightly higher dew points as moisture pools ahead of the front. The Baltimore and Washington office calls Wednesday, quote, the last day of the high heat before temperatures take a 25 to 30 degree nosedive late week. That nosedive is the second act of this story, and it will get its own part of this video. For now, the relevant fact is that the heat dome is locked in for 36 more hours, and the air mass that is doing it is the most anomalous mid-May air mass in the modern record over this region. When you understand the number, the plus 19 to plus 23 degrees Celsius at 850 millibars, the 2 to 3 standard deviations above climatology, everything else falls into place. The records that are about to fall, the advisories that are out, the cascading public health consequences, the dynamical mechanism that put this air mass exactly where it is, on exactly this schedule. All of it follows from the number. Hold that number in your head. We are coming back to it. There are two kinds of temperature records, and the difference between them matters more than almost any weather coverage admits. The first kind is the daily high temperature record, the hottest reading at the official station on a given calendar date, going back as far as the climatological record for that station extends. Daily high records are what gets reported on the news. When the Philadelphia airport hits 97 today, and the previous May 19th record was 92 from 1962, the headline will read, Philadelphia ties or breaks May 19th all-time daily high record. That is the visible record. That is the one that gets the graphic. The second kind is the warmest overnight low record, the warmest minimum temperature recorded at the official station on a given calendar date, going back as far as the record extends. If Philadelphia's overnight low tonight is 68 degrees, and the previous warmest low for May 19th was 65 from 1999, the warmest low record falls. That kind of record almost never gets a graphic. It rarely gets a sentence. But climatologically, it is the more important record of the two. Here is why. A daily high record is set by the conditions during the day. Strong insulation, cloud-free skies, a dry boundary layer, a southerly wind off a heated land surface. It is local. It is transient. It happens during the hours when the atmosphere has the most energy coming in and the most ability to convert that energy into surface temperature. A daily high record tells you something about the peak forcing on a single afternoon. A warmest low record is set during the part of the day when the energy is flowing out, not in. At night, with the sun gone, the atmospheric column radiates long-wave infrared energy upward to space. The minimum temperature you observe in the pre-dawn hours is set by how efficiently the column can shed that energy. And the efficiency of long-wave cooling is sensitive to things the daily high temperature is not sensitive to the moisture content of the column, to the cloud cover, to the temperature structure aloft, and increasingly to the greenhouse gas content of the atmosphere. When you trap long-wave radiation in the column, you raise the minimum temperature you can reach overnight. A warmest low record is a fingerprint of the atmospheric column's radiative state. A daily high record is a fingerprint of one afternoon's forcing. This is why, when the United States climatological data are sliced for the last 50 years, warmest low records have been falling at approximately twice the rate of warmest high records. The greenhouse effect is most visible at the moment when the planet is trying to cool itself off, because that is the moment when the trapped long-wave radiation has the most leverage. A warmest low record is the kind of record that, once it falls, tends to keep falling, because the structural cause of the falling is itself trending in one direction. The Philadelphia Forecast Office wrote a single sentence into their morning discussion that you would have missed unless you were looking for it. They wrote, quote, "Lows will only be in the mid-60s to low 70s, which will challenge daily warmest low temperature records for May 19th. That sentence is doing the same kind of work as the 850-millibar number from the last part. It is the climatologically loaded sentence in an otherwise operational forecast discussion. The Philadelphia office is telling you, on the record, that tonight's lows and tomorrow night's lows are going to challenge the warmest low records for the date. When you put the two record types together in the same 48-hour window, challenging the daytime high record and the overnight low record, you are no longer dealing with a one-afternoon forcing anomaly. You are dealing with an air mass anomaly. The integrated column is hot. It is hot during the day because the sun is hammering it. It is hot at night because the column itself is so saturated with thermal energy that it cannot shed enough of that energy to cool to normal mid-May overnight values. That is the 2 to 3 standard deviation, 850 millibar number from part 1, showing up as a fingerprint on the daily climate record. This is the part of the event that historians will, I suspect, focus on when they look back at mid-May 2026, not the 97 on the afternoon thermometer in Washington. That kind of reading happens. It is rare, but it happens. What is rarer is the column integrated heat that produces both the daytime spike and the nighttime non-cooling at the same time, in the same week, across the same 600-mile north-south stretch of the eastern seaboard. The records that fall in the next 48 hours will be litigated in the news. The climate signal embedded in those records is the part that does not get litigated. It just sits in the dataset, accumulating And a decade from now, somebody pulls the warmest low records for May 19th across the I-95 corridor and notices that the trend line is unmistakable. And the question changes from, did we break the record, to when did the climatology shift enough that breaking the record stopped being remarkable? That is a different question, and it is the question this event is really asking. There is one more thing about the records that is worth surfacing now, because it will matter when the cold front arrives Wednesday. The prefrontal trough that ushers the front into the region tends to spike the temperature one final time on the afternoon of frontal passage. So tomorrow's high in the lower 90s is itself a prefrontal peak. The actual ridge collapse begins as the front passes, and the temperature falls quickly afterward. That is the mechanism that produces the 25 to 30 degree drop into Thursday. The records that fall tomorrow are the last record-setting opportunity before the air mass leaves. After Wednesday, this air mass is gone, and the next chance to break a mid-May warmest low record at most of these stations is May 19th, 2027. That gives you a sense of how compressed the climatological window is. The kind of record-setting heat we are watching today and tomorrow had to thread the calendar window precisely between the late-season cold push and the early-season trough wave that is about to break the dome. The air mass got to the right place at the right time to do this. The air mass left the source region where this kind of midsummer heat lives, somewhere in the subtropical high-pressure belt off the southeast U.S. coast, and rode the southerly flow at the right altitude into the right latitude window to set the records. That is a sequence of physical alignments, and it is the sequence that, in the published climate attribution literature, is becoming more common. We will come back to that literature in Act 3. For now, the records. The National Weather Service Office for New York City wrote a sentence into their morning discussion that should be quoted with no commentary first. Quote, "This is the first high heat index event of the year for NE, NJ, and NYC." Read that sentence twice. It is the first event of the year. In May, 2 months ahead of when New York City normally issues a high heat index advisory. The OKX Forecast Office, which covers the New York City Metro, Northeast New Jersey, the Lower Hudson Valley, and interior Southern Connecticut, has put their region into a heat advisory from 11 o'clock this morning, Tuesday, May 19th, until 8 o'clock tomorrow evening, Wednesday, May 20th. That is roughly 33 continuous hours of advisory time. It is the first such advisory issued in 2026. It is being issued in mid-May for an event that nearly any other year would not have happened until mid-July. The heat advisory is not just a New York City thing. The cascade runs the entire I-95 corridor. The Philadelphia Forecast Office has a heat advisory across much of their region, including most of the area where the heat index criterion starts at 100 degrees, with the urban I-95 corridor criterion lowered to 96 degrees through the month of June. The Baltimore and Washington office has a heat advisory in effect with record high challenges throughout. The Boston office has a heat advisory remaining in effect for much of southern New England, Tuesday and Wednesday. Maryland is covered. Inland Virginia is covered. The eastern Pennsylvania corridor is covered. Together, the heat advisory zones from northern Virginia to southern New England encompass roughly 50 million Americans. There is one phrase that shows up in the morning discussions of multiple offices, and it is the phrase that explains the cascade. The phrase is lack of acclimation. Human bodies are remarkably good at adapting to heat over time. If you live somewhere where summer temperatures regularly hit the upper 90s, by mid-July, your body has rebuilt its thermoregulation. Your sweat glands respond faster. Your blood plasma volume expands. Your kidneys retain electrolytes more efficiently. The same 95-degree afternoon that would have put you in the emergency room in early June becomes a routine summer day in late July. The adaptation is real. It is measurable in physiological studies, and it takes roughly 10 to 14 days of repeated heat exposure to develop. In mid-May, none of that adaptation has happened yet. The same 95-degree afternoon that a Philadelphia office worker would handle without thinking. In late August becomes a medical event in mid-May because the body has not yet built the physiological tools to handle it. Cardiovascular load increases, sweat rates lag, core temperature climbs faster. The heat-related illness emergency room admission rates for the same air temperature are dramatically higher early in the warm season than they are late in it, and this is well documented in the epidemiological literature. The National Weather Service knows this. Their forecasters write the words "lack of acclimation" into the discussion as the operational reason they are issuing the advisory at a lower threshold than they would issue it at in July. The Baltimore and Washington office says exactly this. Quote, "The potential greater impacts, lack of acclimation, is driving our decision." In other words, the temperature is high, but not record-shatteringly high in absolute terms. What pushes it across the advisory threshold is the calendar. The bodies on the ground are May bodies, not July bodies. The infrastructure on the ground is May infrastructure. Air conditioners that have not been used in months. Schools that have not yet calibrated their early summer programming. Outdoor work crews who have not built up the sweat and electrolyte rhythm of full summer. There is a secondary public health consequence of this heat dome that almost never gets surfaced in the breaking news framing. The morning data shows 24 active air quality alerts across the country. 24. In mid-May. That count is high. The reason is that a strong upper-level ridge does two things to the air sitting beneath it. First, it suppresses vertical mixing. The air becomes stagnant. Pollutants that would normally vent upward and dilute remain trapped in the lower troposphere. Second, the intense insulation that the ridge enables, clear skies, no convective mixing, high sun angle, drives photochemical reactions between nitrogen oxides and volatile organic compounds, producing ground-level ozone at rates well above the urban summer baseline. When you combine those two effects, you get air quality degradation that maps almost exactly onto the heat advisory zones, plus a public health load that compounds the heat stress load. The advisories will mention the heat. The same population is also being exposed to a respiratory load that is invisible and unmentioned. People with asthma, COPD, cardiovascular disease, and the elderly are facing a multi-system stress event that gets reported as a heat wave. The cascade, heat advisory zones, urban acclimation threshold, ozone formation, ER admissions, is the operational consequence of the air mass diagnosis from Part 1. It is what happens on the ground when a 2 to 3 standard deviation, 850-millibar anomaly sits over 50 million people for 36 hours in May. The geography of who gets hit is itself worth thinking about for a moment. The I-95 corridor is the most populated stretch of land in the United States. It contains a disproportionate share of the country's elderly population in concentrated urban environments. It contains the older housing stock that is least likely to have central air conditioning. It contains the urban heat island infrastructure that pushes overnight lows several degrees above what surrounding rural areas experience. When you put a heat dome across that specific corridor in mid-May, the public health exposure is not evenly distributed. The cascade falls hardest on the populations that are already the most vulnerable, in the months when the support systems that exist for full summer heat have not yet activated. The advisories are out. The infrastructure is responding as it can. Cooling centers will open. Utility companies will brace for load. Hospital emergency departments will see an uptick over the next 48 to 72 hours. The advisory cascade is the National Weather Service doing its job exactly as designed, on an air mass that is well outside the design envelope of the late spring calendar. The deeper question, the one that the cascade does not by itself answer, is the question we will spend the rest of this video on. Why is this air mass here in May? And why does it feel surprising when the published science predicted it would arrive on roughly this schedule. There is a published scientific literature on heat domes, and it is more developed than most weather coverage admits. The mechanism is straightforward, even if the math is not. A high-pressure ridge forms aloft, anchored over a region by the combination of the upper-level wave pattern and the surface high-pressure system underneath it. Once the ridge is in place, it does several things at once, all of which reinforce each other. It suppresses cloud formation. The skies clear. Insolation increases. The ground heats up. The ground re-radiates long-wave infrared back into the lower atmosphere. The lower atmosphere heats up. The warmer lower atmosphere produces a positive thermal anomaly that further supports the ridge above it. The ridge becomes self-reinforcing. The cloud-free conditions persist. The ground heats further. The cycle continues. This is what meteorologists call a heat dome positive feedback loop, and it has been characterized in the published literature for at least 20 years. Schubert and collaborators published foundational work on Western North American heat dome dynamics in the early 2000s. Domeisen and collaborators have published more recent work on European heat dome persistence. The mechanism is well understood. What has changed in the recent literature is not the mechanism. What has changed is the frequency and the intensity. Heat domes that, in the climatology of 1960, would form once a decade are now forming every year or two. Heat domes that, in 1960, would peak 2 or 3 sigma above climatology now peak at 4 or 5 sigma above climatology. The structural shape of the event is unchanged. The amplitude and the calendar position have shifted. The reason a heat dome should not exist in May is that the source air mass that feeds a heat dome, the subtropical high-pressure belt that sits off the southeastern United States in summer, does not normally migrate this far north in mid-May. The mid-May climatological position of that belt is several hundred miles south of where the current ridge axis is anchored. For the belt to deliver an air mass with plus 18 to plus 23 degrees Celsius at 850 millibars into the latitude window of Washington, New York, and Boston, the upper-level circulation has to do something unusual. The polar jet has to retreat far enough north to allow the subtropical air mass to flow into the mid-latitudes, uninterrupted. The ridge has to anchor high enough latitude to lock the flow in place for several days. The blocking pattern has to develop quickly enough to produce a coherent ridge before the next trough wave displaces it. All of those things happened. When you look at the upper-level forecast charts for this week, you see a textbook setup. The polar jet has retreated well into Canada. The subtropical jet is suppressed southward over the Caribbean. Between them, a wide latitude band of slow westerly flow contains the developing ridge over the southeast, with the ridge axis tilting northeastward into the mid-Atlantic over the next 48 hours. The configuration is what the dynamical literature calls a high-amplitude blocking pattern, and it is exactly the kind of pattern that the Petukov-Kumuman literature, which we will return to in Part 7, predicts will increase under continued Arctic warming. What is unusual about this particular event is not the existence of the blocking pattern. Blocking patterns happen. What is unusual is the timing. A blocking pattern that delivers a midsummer air mass into mid-May territory is the calendar shift, not the dynamical event. The dynamics have always been able to do this. What has changed is the climatology window in which the dynamics can pull it off. The published heat dome literature would tell you that an event like this, in May, at this latitude, with this amplitude, would have a return interval somewhere between 50 and 300 years on the climatology of 1970. The return interval on the climatology of 2026 is on the order of 10 to 30 years. That is a 1 order of magnitude shift in the recurrence interval over 50 years. That shift is the climate signal. The event is the messenger. The Philadelphia office writes that the ridge will, quote, remain in place through late this evening before it starts to flatten on its northwest side during Wednesday. The flattening is the cold front arriving. The flattening is the dynamical event that ends the dome. But the dome itself, the ridge that is producing the heat, will hold through tomorrow afternoon. That is roughly 36 more hours of plus 19 to plus 23 degrees Celsius at 850 millibars, sitting over 50 million Americans. There is one more piece of the mechanism worth surfacing. The fact that the ridge is anchored off the southeast U.S. coast in the Atlantic, rather than over the interior of the continent, means that the surface high-pressure system underneath it is the Western Atlantic subtropical high. That is the same surface high that, in the summer climatology, drives the trade winds across the Caribbean and the southerly flow of Gulf moisture into the eastern United States. In mid-May, this high should be weaker and located further south. The fact that it is acting like a July high in mid-May is what allows the upper ridge to anchor in the right position to produce the dome. The two systems are coupled. The surface high and the upper ridge are reinforcing each other through deep layer thermal advection. That coupling is what makes the dome stable for the multi-day window we are watching. When the cold front arrives Wednesday afternoon, the coupling breaks. The surface high retreats. The upper ridge flattens. The thermal advection from the south reverses. The air mass that has been sitting over us for the better part of a week is replaced, almost overnight, by an air mass that is 25 to 30 degrees Fahrenheit cooler. The dome ends. The records, if they fall, are in the books. The advisories expire. The cascade subsides. But the air mass anomaly does not subside. The conditions that allowed this air mass to exist in mid-May, the high amplitude blocking pattern, the northward retreat of the polar jet, the Atlantic subtropical high running ahead of schedule, those conditions are themselves the climate fingerprint. They are not weather. They are climatology shifting under the weather. Hold that distinction. We will come back to it. Right now, the next thing to understand is what happens when the dome ends, because the ending is not gentle. The cold front that ends the heat dome is not a passive shift in temperature. It is its own event, and it is its own hazard. The Storm Prediction Center, which is the National Weather Service unit responsible for forecasting severe thunderstorm and tornado risk, issued their Day 2 convective outlook this morning. Day 2 means the period from 12 UTC Wednesday, May 20th, through 12 UTC Thursday, May 21st, essentially Wednesday afternoon, evening, and overnight into early Thursday. In that window, the Storm Prediction Center has placed a slight risk for severe thunderstorms across a region stretching from the Cumberland Plateau in eastern Kentucky and Tennessee, northeastward through the Mid-Atlantic into southern New England. Slight risk is level 2 of 5 on the Storm Prediction Center's risk hierarchy. It is one notch above the marginal risk that they used for today, and it indicates that organized severe storms with the potential for damaging winds and large hail are expected within the highlighted area. The mechanism is the textbook collision between a hot, moist, unstable warm sector air mass and the leading edge of a cooler, drier air mass behind a strong cold front. The Storm Prediction Center's discussion this morning lays it out cleanly. Boundary layer dew points in the mid-50s to low 60s combine with steep mid-level lapse rates to produce mean layer convective available potential energy values between 1,000 and 2,000 joules per kilogram. That is enough instability to support strong convection. Convergence along the front itself, plus terrain, influences across the Cumberland Plateau and the Appalachian foothills are expected to foster an increase in thunderstorm coverage and intensity through Wednesday afternoon. The strongest vertical wind shear, which is what allows storms to organize into supercells or bowing line segments, is concentrated north of the surface warm sector. That, combined with relatively poor mid-level lapse rates over the warm sector itself, suggests that the storm mode will favor damaging downburst winds from well-mixed boundary layers rather than long-track supercells. but marginally severe hail is also expected to occur, and the Storm Prediction Center has explicitly flagged both hazards. The forecast confidence is being reinforced by external models. NCR's AI-based numerical weather prediction, Convective Hazards Forecast, has placed the Washington-Baltimore region in a 45 to 60% probability of severe weather Wednesday afternoon and evening. Colorado State University's day. Two probabilities are running between 15 and 30%. These are independent automated systems converging on the same conclusion as the Storm Prediction Center's human forecasters. When the AI consensus, the academic consensus, and the operational consensus all agree on a slight risk, the event is locked in. The Boston Forecast Office is expecting better chances for strong to severe thunderstorms Wednesday across southern New England, with strong damaging winds as the main risk. Their estimated surface-based convective available potential energy is 1,000 to 1,500 joules per kilogram, with 0 to 6 kilometer bulk shear values of 25 to 30 knots. Sufficient for organized convection, but not the extreme shear that would produce a major tornado outbreak. The Mid-Atlantic states will see a similar profile. The compound nature of the event is the part that does not get the attention it deserves. There is a published climate impacts literature on compound hazards, events in which multiple acute stressors hit the same population in a short window. The most cited reference is Scheichler and collaborators, who published a Nature climate change paper in 2018 titled Future Climate Risk from Compound Events. Their core argument is that the human and infrastructural impacts of compound events scale superlinearly with the number of co-occurring stressors. A population that has been heat exhausted for 48 hours, with sleep disruption from the warm overnight lows, with elevated cardiovascular load from the lack of acclimation, with the strain on emergency services that always accompanies a heat advisory, is not a baseline population when the severe storm threat arrives Wednesday afternoon. They are a degraded population. Their reaction times are slower. Their decision-making is impaired. Their willingness to take a damaging wind warning seriously is reduced by the simple fact that they have been receiving warnings continuously for 3 days. This is the operational reason that emergency management agencies care about compound events, independently of any climate attribution conversation. The cumulative load is what breaks systems. A 2-day heat wave on its own is manageable. A 2-day heat wave followed by an organized severe thunderstorm outbreak, followed by a sharp temperature crash that re-stresses utility infrastructure, is a 6-day operational nightmare for the same county-level emergency manager who already burned out their staff on the heat. The heat is the front end of the story. The cold front is the back end. They are the same weather system. The air mass anomaly that produced the dome is the same air mass anomaly that produced the gradient between the warm sector and the postfrontal air. The size of the severe weather risk is proportional to the size of the heat anomaly that is feeding it. When you compress the temperature gradient between the air masses, you load up the kinetic energy that the cold front can release at the boundary. The reason the Storm Prediction Center has a slight risk Wednesday is the same reason the Boston office has been talking about 2 to 3 standard deviations all morning. The atmosphere is not in equilibrium with itself. The collision is the system's way of restoring equilibrium, fast. When the rebalancing finishes, the gradient is gone. Thursday will be cooler, drier, and quieter. The same population that just absorbed the heat will absorb the storms, and then will absorb the temperature crash in roughly that order across 36 hours. The compound window is the operational reality of the next 6 days. The air mass anomaly that we opened this video describing is the engine that is making all of it happen. The Baltimore and Washington Forecast Office wrote a single line into their morning discussion that does not get the attention it deserves. Quote, Wednesday will mark the last day of the high heat before temperatures take a 25 to 30 degree nosedive late week. A 25 to 30 degree single-day temperature drop in mid-May is itself outside the climatological envelope. Standard mid-May cold fronts in the eastern United States typically produce a 10 to 15 degree drop. Strong fronts, the kind that arrive once or twice a season, can produce 20 degree drops. A 25 to 30 degree drop is unusual. The mechanism is the size of the thermal gradient between the air masses that are colliding, which is itself a function of the strength of the ridge being collapsed. In other words, the size of the drop is the size of the anomaly. If you wanted to measure how unusual the heat dome was, you could look at the 850 millibar temperatures, which is what we did in part 1. Or you could look at the post-front temperature crash, which carries the same information from the other direction. They are two measurements of the same atmospheric disequilibrium. The 2 to 3 standard deviation pre-front anomaly and the 25 to 30 degree post-front drop are the same number, viewed from different sides. The New York City Forecast Office sees the same pattern from their side. Their morning discussion notes a, quote, much cooler air mass expected Thursday into the holiday weekend with chances of showers. Memorial Day weekend, which begins Friday, May 22nd this year, will run cool, unsettled, and showery across the entire Northeast and Mid-Atlantic. The Boston office is hedging. They call for, quote, cooler and unsettled, weather is possible Memorial Day weekend, but confidence remains low. That confidence hedge is itself informative. The post-front pattern is unsettled enough that even the deterministic forecast model guidance is struggling to commit on the specifics 3 days out. For the operational story of the next 6 days, the post-front crash matters in 3 specific ways. First, it produces sharp utility load swings. Air conditioning runs at peak Wednesday afternoon, then collapses by Thursday morning. Then heating systems may reactivate by Thursday night in northern parts of the region. Sudden load swings stress grid infrastructure in ways that steady high or steady low loads do not. Second, the crash will produce widespread fog, drizzle, and visibility issues across the Memorial Day weekend travel window, the busiest non-Thanksgiving travel weekend of the year. Third, the temperature differential will produce uncomfortable transitions for the same population that just exhausted itself on heat. A 50-degree morning following an 85-degree afternoon is the kind of weather that produces respiratory infections, sleep disruption, and emergency department visits for vulnerable populations. The post-front cool down is not a relief. It is the third act of the same event. The same air mass anomaly that produced the heat is producing the storm threat, is producing the crash, is producing the cool weekend. It is one weather system, end to end, and it is doing all of it because the 850 millibar temperatures over the Northeast are running 2 to 3 standard deviations outside normal in mid-May. The size of the air mass anomaly is the size of every consequence that follows from it. Hold the number. We are coming back to it one more time. This morning, while the Philadelphia airport climbs toward 97, the airport in Bismarck, North Dakota is sitting near freezing. The National Weather Service office in Bismarck has freeze warnings active for portions of north central and south central North Dakota tonight through Wednesday morning. The Twin Cities office has frost advisories active across central and southern Minnesota. The Denver office has freeze warnings and frost advisories across most of the eastern Colorado plains. The Bismarck office wrote into their morning discussion that, quote, freeze warning is in effect tonight through Wednesday morning. That is the same morning in the same country on which the Philadelphia office is calling for 97-degree afternoons and warmest overnight low records. This is not a coincidence. It is a textbook signature. The atmospheric pattern that produces a strong, anchored ridge over the southeast United States is the same pattern that produces a sharp trough on the western side of the ridge axis. Ridges and troughs come in pairs. When the eastern third of the continent is locked under a high-amplitude ridge, The central and northern plains are locked under the complementary trough. The trough pulls cold air down from Canada. The ridge pushes warm air up from the subtropics. The two structures lock together into what dynamical meteorologists call a high-amplitude planetary wave pattern. The pattern is stuck. The ridge and trough hold position, while the underlying westerly flow moves through them. So the weather at any given longitude does not change much from day to day until the entire wave pattern breaks down. The plains frost-east heat continental gradient is the visible fingerprint of a high-amplitude jet stream. It is the kind of pattern that, on a hemispheric chart, looks like the polar jet has bent itself into a deep S-curve, with the southern lobe over the central plains and the northern lobe arching over the mid-Atlantic into the western Atlantic. The amplitude of the wave is what produces both the cold to the west and the heat to the east, simultaneously, on the same morning, 600 miles apart. There is a peer-reviewed published literature on why these high-amplitude patterns appear to be increasing in frequency. The foundational paper is by Petukov, Rahmstorf, Petri, and Schellenhuber, published in the Proceedings of the National Academy of Sciences in 2013. The title is Quasi-Resonant Amplification of Planetary Waves and Recent Northern Hemisphere Weather Extremes. Their argument is technical, but it can be stated simply. The strength of the polar jet stream depends on the temperature contrast between the polar region and the mid-latitudes. The Arctic has been warming faster than the global average, roughly 2 to 4 times faster, depending on the metric and the time window. As the temperature contrast weakens, the jet stream weakens. A weaker jet meanders into higher amplitude patterns more easily. Higher amplitude patterns become stuck more often, producing prolonged heat events in some longitudes and prolonged cold events in others. The pattern we are watching today, a deep ridge over the east, a deep trough over the plains, with both holding position for multiple days, is exactly the kind of pattern that Petukov, Rahmstorf, and their collaborators predicted in 2013 would become more common under continued Arctic warming. Kumu, Petukov, Rahmstorf, Petri, and Schellenhuber extended this work in PNAS in 2014. Mann, Rahmstorf, Kornhuber, Steinman, Miller, and Kumu published in Scientific Reports in 2017, finding the same signature in observational data spanning the late 20th and early 21st centuries. The Petukov-Kumu-Mann line of research is mainstream peer-reviewed climate dynamics. It is not contested at the level of the underlying mechanism. What is debated in the literature is the magnitude of the signal. How much of the observed increase in high-amplitude patterns is attributable to Arctic amplification specifically, versus other drivers like changes in tropical sea surface temperature patterns or stratospheric variability? The mechanism itself is settled science. The frequency increase is observed. The attribution to Arctic warming is the active research question. The relevance to the morning of May 19, 2026, is that the plains frost-east heat continental gradient currently sitting over the United States is the visible fingerprint of exactly the kind of high-amplitude pattern that the Petukov-Kumu-Mann literature predicts will become more common. The pattern produced 2021's Pacific Northwest heat dome, which killed roughly 600 people across the region and produced the all-time Canadian record of 121.3 degrees Fahrenheit at Lytton, British Columbia, the day before the town burned down. The pattern produced the United Kingdom's first 40 degrees Celsius reading in recorded history in July 2022. The pattern produced the European heat of summer 2003, which killed roughly 70,000 people across the continent. The pattern produced the multi-state heat record event of March 2026, which broke statewide all-time March records across 14 U.S. states. The 2021 Pacific Northwest event was the subject of formal rapid attribution analysis by the World Weather Attribution Group within days of the event. Their finding was that the event was approximately 150 times more likely under the current warming climate than under a pre-industrial baseline, and the peak temperature was at least 2 degrees Celsius hotter than it would have been without warming. The 2022 UK event was found to be approximately 10 times more likely under current warming. The 2003 European event was found, retrospectively, to be approximately twice as likely. The signal across all three events is consistent. Anthropogenic warming does not cause individual heat events. It sharply increases their probability and their peak intensity, and the effect grows with event extremity. The mid-May 2026 event we are watching today does not yet have a formal attribution study. The methodology takes weeks to months, but the pre-event diagnostics, the 850-millibar anomaly, the 2 to 3 sigma framing, the multi-office record language convergence, the continental plains frost east heat gradient, the persistent ridge anchored off the southeast coast, all align with the structural fingerprint that the published literature has identified as the high-confidence climate warming amplified pattern. This is the part of the story that, in any normal news cycle, does not survive the transition from the breaking news framing to the public conversation about the event. The records will be reported. The advisories will be reported. The severe weather Wednesday will be reported. The post-front crash and the cool Memorial Day weekend will be reported. The climate framing, that this event is one more data point in a pattern that the published science predicted would happen on roughly this schedule, will appear in a few outlets, in a few sentences, near the end of the article. The structural reality is that climate framing tracks event severity and event duration. Brief events get less framing than prolonged ones. Events without casualties get less framing than events with casualties. That structural reality is not suppression. It is media cycle logic. The corrective is to surface the climate context inside the breaking news framing, which is what this video is doing. The reason it feels surprising that a mid-May air mass is 2 to 3 standard deviations outside normal is that the institutional pipeline that delivers the weather to the public separates the operational forecast from the climate context. The forecast is in your phone. The context is in a journal article you will not read. Closing that gap is the work of the next decade of weather communication, and it is the work this video is trying to do in 8,000 words. The phrase, "what they're not telling you," deserves to be unpacked, because it is doing two different things at once, and only one of them is honest. The honest version is what we just walked through. The National Weather Service writes weather products, not climate products. Their forecaster's job is to nowcast the atmosphere, not to attribute it. When the Philadelphia office writes record-setting early season heat probable into their morning discussion, that is a weather statement. The climate statement that mid-May 2 to 3 sigma heat events are becoming dramatically more common under continued warming is true, and it is the responsibility of a different scientific community, and it is rarely included in the same product. This is not suppression. It is institutional division of labor. The result, however, is real. The average reader of a forecast discussion gets the weather without the climate context, and the average reader of a climate article does not get the operational forecast. The gap is structural. Closing it is fair work. That is the honest, what they're not telling you, framing, and it is the framing this video has been operating in for the last hour. The dishonest version is the broader conspiracy framing that high-amplitude jet patterns, heat domes, and severe weather collisions are evidence of weather modification, geoengineering, or deliberate atmospheric manipulation. The most cited target of this framing is the High-Frequency Active Auroral Research Program, a research facility at Gacona, Alaska, that uses a high-powered radio transmitter to heat the ionosphere for atmospheric research purposes. The acronym is HAARP. The conspiracy claim is that HAARP is being used to steer jet streams, produce heat domes, and engineer weather patterns. The claim does not survive contact with the energy budget. HAARP, at its operational peak, transmits at roughly 3.6 megawatts of high-frequency radio power directed upward into the ionosphere. The transmitter operates for at most a few hours at a time. If you ran it continuously for 24 hours at full power, the total energy deposited into the upper atmosphere would be on the order of 3 times 10 to the 11th joules. That is 300 billion joules. It is a lot of energy in human terms, comparable to roughly 70 tons of TNT. A continental-scale heat dome at the 2 sigma level represents an integrated thermal anomaly on the order of 10 to the 20th to 10 to the 21st joules per day across the affected region. That is 100 quintillion joules per day. The ratio between HAARP's daily output and the heat dome's daily thermal load is 9 to 10 orders of magnitude. HAARP, run continuously for 24 hours at full power, deposits roughly 1/10 billionth of the energy that the heat dome is currently moving through the atmosphere over the northeast. There is no physical mechanism by which an ionospheric heater modulates lower tropospheric ridge structure. The ionosphere and the lower troposphere are coupled in subtle ways that affect things like long wavelength radio propagation and certain narrow electromagnetic phenomena, but they are not coupled in ways that move air mass anomalies of the size required to produce a heat dome. The physics simply does not work. The conspiracy framing is energetically impossible by something like a factor of 10 billion, and the reason it persists is not that there is evidence for it. The reason it persists is that the consequences of high-amplitude jet patterns are intuitively unnerving, and they are doing this to us is a more emotionally satisfying explanation than the planet is in a slow thermodynamic disequilibrium, and the math says this will keep happening. The related conspiracy framings about chemtrails, persistent contrails from commercial aviation interpreted as deliberate atmospheric seeding, and about cloud seeding programs as engines of heat dome formation are similarly disposed of by the same energy budget argument. Cloud seeding can locally enhance precipitation by 10 to 15% under the right conditions. It cannot generate or sustain a continental scale ridge. Persistent contrails are composed of water ice, carbon dioxide, water vapor, and small amounts of soot from the engines. Their chemistry is well characterized by atmospheric science, and they are not the vector for atmospheric manipulation that the framing suggests. The honest, what they're not telling you. Framing surfaces the institutional weather-climate gap. The dishonest version invokes geoengineering, weather modification, and atmospheric warfare. The first is fair and useful. The second is energetically impossible. There is a third thing worth surfacing, which is the broader narrative that mainstream media downplays climate-related weather events. The data is mixed and worth being honest about. Some events get extensive coverage that explicitly names attribution. The 2021 Pacific Northwest Dome was covered with attribution language by PBS, the BBC, Reuters, and most major newspapers. The 2022 UK 40-degree event was covered with attribution language across European and American outlets. The March 2026 multi-state heat record event was covered by PBS, The Washington Post, AccuWeather, and CNN with attribution language. The mid-May 2026 event is breaking today, and the level of climate framing and coverage will depend partly on whether the records actually fall, and partly on whether the severe weather Wednesday produces casualties. The structural reality is that climate framing tracks event severity and event duration. Brief events get less framing than prolonged ones. Events without casualties get less framing than events with casualties. This is media cycle logic, not conspiracy. It is fair to call out. It is not evidence of suppression. Now, the closing. The 850-millibar air mass currently sitting over the northeast is plus 19 to plus 23 degrees Celsius. It is 2 to 3 standard deviations outside normal for mid-May. It will produce record daytime highs and record warmest overnight lows across the I-95 corridor over the next 36 hours. It will collide with a cold front Wednesday afternoon and evening that will produce a slight risk severe thunderstorm threat across the same region. It will be followed by a 25 to 30 degree temperature crash into a cool, unsettled Memorial Day weekend. The pattern that put it here is a high amplitude blocking pattern with simultaneous plains frost and east heat, which is the textbook fingerprint of a meandering polar jet under continued Arctic warming. The published science of Ptokoff, Kumu, Mann, Rahmstorf, and Schubert predicted this kind of pattern would become more common on roughly this schedule. The mechanism is well understood. The frequency increase is observed. The event we are watching is one more data point. The pattern is alarming. It is also explained. Both of those things can be true. The mystery is not in the data. The data is unambiguous. The mystery is in why the climate framing remains separated from the weather framing inside the institutional pipeline that delivers the forecast to the public. And the answer to that mystery is the work of the next decade of weather communication. The records will fall over the next 48 hours, or they will fall on the next event, or they will fall on the one after that. They will fall, and they will fall again, and they will keep falling. And the question we ought to be asking is not whether the records will fall, but when the climatology will have shifted enough that breaking the record stops being remarkable. That is a different question. It is the question this event is really asking. And it is the question that the air mass currently sitting over your head, in May, 2 to 3 standard deviations outside normal, is asking on behalf of every other event that is coming. Hold the number, plus 19 to plus 23 degrees Celsius, at 850 millibars in mid-May. That is the number. Everything else is a consequence.